Welcome, future calculus students. Today we're going to be looking at the chain rule. The chain rule is a derivative rule, that we use whenever we're taking the derivative of a composite function. Remember, composite function is where you have one function inside the other. So here we have f, and inside of f, instead of just having an x, we have g of x. We have another function inside. And the way the chain rule works, when we want to take the derivative of a composite function, the rule is written like this. You take the derivative of the outside, leave the inside alone, times the derivative of the inside. Now, this function, having tutored calculus for many students before I even taught it, would always confuse students because they always felt they didn't know when to stop taking the derivative, because they're like, if I keep going, I'll eventually go to zero if they have a polynomial expression. And so I'm going to show you how we use this rule correctly, and then I'll show you a different way that will help prevent you from being lost on when do you stop taking the derivative. So let's use this rule for this example here. We're going to find the derivative of sine of 4x squared. Well, using this rule, we're going to take the derivative of the outer piece. That's cosine. So the derivative of sine is cosine. And we're going to leave the inside alone and then take its derivative. So if we do this, again, identifying our outer and inner function, the derivative of sine is cosine. We leave the inside alone, and then we take the derivative of the inside, which would be 8x. The derivative of 4x squared is 8x, and then we would write it where the 8x goes in front with the times cosine 4x squared. So that is the chain rule. You take the derivative of the outside and then multiply it by the derivative of the inside. So the way I like to teach the chain rule is to actually work inside out. Now, anytime we've been dealing with parentheses, the order of operations has always come up. You do parentheses first. Well, you do exponents first, but then you focus on parentheses. Parentheses are a grouping symbol, and it's one of the operations that we use. It's not really an operation, but it's a grouping method that we use. We always say do parentheses first. So with chain rule, I'm like, why do we change that? And that's when I found this inside out method, which is where you actually start with what's in the parenthesis. So in this case, when you identify that you have a composite function, one function inside the other, the way that we do this is, or the way that I do it is I say, okay, well, I have this inner function here, 4x squared. The derivative of 4x squared is 8x. And I'm going to highlight that yellow just to show that this 8x came from the derivative of 4x squared. Now I'm going to multiply that by the derivative of the outer piece. Well, the outer piece is sine. The derivative of sine is cosine. Now, I've already used 4x squared. I already took its derivative, so I'm just going to leave it alone in here. It's been neutralized. So as I work inside out, everything that was inside gets neutralized. I've already taken care of it. So the derivative of 4x squared is 8x times the derivative of sine, which would be cosine. And then the 4x squared just comes along with the right because it's already been neutralized. And so this is our answer here. And it's the same answer that we had on the top. There's no need to worry about, wait, how do I know when to stop? Do I take the derivative of 8x or do I keep and say times 8? No, this tells you start from the inside. And if you have everything highlighted, that means you've accounted for everything. That's why I really like this inside out method. Now here's another example. I have for problem 2, we have e to the 9x squared plus 6x. Again, I recognize that this is a composite function. I have the function e, and then I have this function here where it's normally just x, but now it's 9x squared plus 6x. So in this case, we're going to take the derivative of the inner piece, the derivative of 9x squared plus 6x. That would be 18x plus 6. Because this has more than one term, I'm putting it in parentheses because it's going to be this entire derivative times the derivative of the outer piece. Well, now the outer piece is e. Well, what's the derivative of e to the x? Well, e to the x is just e to the x. That's the derivative. So this is going to be times e. And then since we've already taken the derivative of this stays the same. I'm just putting it in parentheses to make it look nicer. But you don't have to have the parentheses. And this is my answer. There's nothing left on the outer part. This is the derivative of this function. This is how we can use the chain rule. One last example where you have a function inside of another function inside of another function, and this is where I find the inside out method so helpful because it gets really easy to get confused using that rule that we have up here. There's nothing wrong with this rule here. It's completely a valid rule, but as you get more functions, it can just get a little bit easy to get lost. So again, I'm going to start with the innermost piece, which would be this 4x cubed. I'm going to highlight that. The derivative of 4x cubed, well, that's going to be 12x squared times, I'm going to highlight that yellow. Well, I'm done with that inner piece. Now, what's the next outer piece? That would be sine. So I'm going to take the derivative of sine. The derivative of sine is cosine. So I'm going to highlight that in purple, in that purplish color. And I'm going to also include that 4x cubed because we've already neutralized that. We've already used it, so it's no longer we have to worry about taking its derivative. Well, outside of sine is cosine. So I'm going to have to take the derivative of cosine. The derivative of cosine is negative sine. So I'm going to highlight this in green, negative sine. And we've already deactivated or neutralized this sine and this 4x cubed. So that stays exactly the same, sine 4x cubed. And that's our derivative. Now I can make this look nicer. I can put that negative in front. This would be negative 12x squared cosine of 4x cubed times sine of sine 4x cubed. So the point of this is to illustrate, one, the rule that you learned in pre-calculus, which was the chain rule, and how the derivative rule is written for a composite function, and we call that the chain rule. And then also showing you how another technique that I like to refer to as the inside-out method that just kind of helps alleviate some of the stress students get when they don't know when to stop taking the derivative. Like I've said in years past, I would have students who would going to this part here, they'd say, oh, and then the derivative of 8x would be times 8, and the derivative of 8 is 0. Wait, anything times 0 is 0, so does that mean this whole thing is 0? No, students sometimes don't know when to stop. And the inside-out method tells you when to stop because there's nothing else to highlight on the outside. And also, you're working in the order of operations that you're accustomed to since pre-algebra or even before then when you learned your order of operations. So I hope you found this video helpful. Have a good rest of your day.